All right, in the last lesson, we learned about lines and angles and how when you have two lines cut by a transversal, it created four types of angles: corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles, or consecutive interior angles, as I like to call them. So today we're going to talk about what happens when two parallel lines are cut by a transversal, and that creates different relationships between the four pairs of angles. So our postulate 3.1 and theorems 3.1, 3.2, 3.3 deal with the different types of angles that are created when parallel lines are cut by a transversal. So all of these postulates and theorems start out with the same if statement, same hypothesis. If a transversal intersects two parallel lines, then postulate 3.1 states that corresponding angles are congruent. So that is the corresponding angles postulate. Theorem 3.1 is the alternate interior angles theorem, and that states that alternate interior angles are congruent when two parallel lines are cut by a transversal. In addition, if two parallel lines are cut by a transversal, then same side interior angles are supplementary. Once we see a drawing of this, it'll make perfectly good sense. When you look at the angles, they appear to be supplementary angles or add up to 180. And finally, the last theorem, the alternate exterior angles theorem, says if a transversal intersects two parallel lines, then alternate exterior angles are congruent. So let's look at some problems that we can use to identify different angles. The first thing we're going to do is using the graphic organizer, we're going to, in the diagram to the right, we're going to figure out which angle is congruent to what. So postulate 3.1, which says corresponding angles postulate, angle 3 is congruent to the corresponding angle with angle 3, which is angle 1, so angle 3 is congruent to angle 1. Theorem 3.1 says alternate interior angles are congruent. So angle 3 would be congruent to its alternate interior angle, which is angle 7. And finally, 3.3 says alternate exterior angles are congruent. So angle 1 has an alternate exterior angle with angle 5. So one way to justify measure of angle 5 equals 55 is shown below. Can you find another way to justify the measure of angle 5 equals 55? So we could say by the vertical angles theorem that measure of angle 1 is equal to 55. Then by corresponding angles postulate, we could say the measure of angle 1 is equal to, measure of angle 5 is equal to measure of angle 55 because angle 1 and angle 5 are corresponding angles. So let's look at the reason statements here. We have three statements and we're going to give a reason for each. The measure of angle 7 equals 55 degrees. Why is that? Because it is a corresponding angle with the angle that is marked 55 degrees. So by the corresponding angles postulate, measure of angle 7 equals the measure of angle 55. Measure of angle 5 equals the measure of angle 7 because those are two angles that are vertical angles. So we use the vertical angles theorems that says that two angles are congruent or also it means their measures are equal. And finally, we can say that the measure of angle 5 equals 55 by the transitive property of equality. So it's two different ways that we were able to prove that the measure of angle 5 equaled 55. Now we can also do a proof to prove an angle relationship exists. Given that A is parallel to B, we want to prove that angle 1 is congruent to angle 7. So we're going to use the reasons at right to write each step of the proof. So what is given is A is parallel to B. So we write that down. Now it says, the number 2, if two lines are parallel, then corresponding angles are congruent. So we're trying to end up with angle 1 being congruent to angle 7. So we probably want to look at angle 1 and figure out what its corresponding angle is. And that would be angle 5. So we're going to say angle 1 is congruent to angle 5. Congruent angles have equal measure. This is a common thing in proofs. If you say two things are congruent, you're usually saying that to say that their measures are equal. So measure of angle 1 equals the measure of angle 5. We also know that vertical angles are congruent, so we look at angle 5 and say what angle is vertical to that, and that would be angle 7. So we can say angle 5 is congruent to angle 7. Congruent angles have equal measure again, so the measure of angle 5 equals the measure of angle 7. Now you should be able to see what our transitive property is going to give us. Transitive property of congruency is going to be the measure of angle 1, and that really should say the transitive property of equality, because it's the measure of angle 1 equals the measure of angle 7, and now angles with equal measure are congruent, or the definition of congruency, angle 1 is congruent to angle 7. Finally, we're going to look at how to find measures of angles. This is the algebra part y'all like. So we want to find the measure of angle 1. There are two sets of parallel lines, and each parallel line also acts as a transversal. So L is a transversal of P and Q, and M is a transversal of P and Q. In addition, P is a transversal of L and Q is a transversal of L and M. So it creates a whole bunch of alternate interior angles, corresponding angles, alternate exterior angles, and consecutive interior angles. So we're going to look at angle 1 and angle 4. What type of angles are those? So we can say angle 1 is congruent. We can say angle 1 is congruent to angle 4 because they're alternate interior angles, so the alternate interior angles theorem. In addition, we now can say measure of angle 1 equals a measure of angle 4. Congruent angles have the same measure. All right, now I'm going to continue to look at this. I say angle 4 and angle 6 are supplementary. Now angle 4 and angle 6 form what type of pair? They're opposite. They're a non-common side, forms opposite rays. Therefore, they are a linear pair. So by the linear pair postulate, we can say angle 4 and angle 6 are supplementary because linear pairs are supplementary. So the definition of supplementary angles tells us that the measure of angle 4 plus the measure of angle 6 equals 180. Since the measure of angle 1 in step 2 equals the measure of angle 4, I can use substitution, or the transitive property. Measure of angle 1 equals 4, 4 equals 6. So I can say the measure of angle 1 plus the measure of angle 6 equals 180. And then measure of angle 5 equals 105 because of corresponding angles have the same measure. Measure of angle 6 equals 105 because alternate interior angles have the same measure. So I can say the measure of angle 1 plus 105 equals 180. Substitute into statement 5. So statement 5 says measure of angle 1 plus measure of angle 6 equals 180. So I'm just substituting in 105 for measure of angle 6. And finally, we're going to subtract 105 from both sides, and we get that the measure of angle 1 equals 75. Now, there's a whole bunch of ways that we could have done this to get to the measure of angle 1 being 75. Me personally, I would have just said that angle 6 is an alternate interior angle with the measure that's 105. 4 and 6 are a linear pair. So angle 1 is obviously the same as angle 4 because they're alternate interior angles. It's the same thing they did. You could probably do this step proof in about 2 or 3 steps fewer and still get the correct answer. So proofs are not, they're not one set proof each time. Proofs can be proven differently using different statements and reason as long as everything follows it is appropriate and correct. Finally, we're going to look at using algebra to find an angle measure. So in the figure at the right, what are the values of x and y? The bases of the trapezoid are parallel. No, I always forget one line. Are parallel, right? Because they have the little arrows. The arrows on the lines indicate that the two lines are parallel. So we can use the same side interior angles theorem, which says that consecutive or same side interior angles are supplementary to complete each statement. So 2x plus x minus 12 equals 180. And then 3y plus y plus 20 equals 180 also. So we're going to solve each equation. I'm going to let you take some time to do that. It'll take you not too long to solve the first one. So you're going to solve 2x plus x minus 12 equals 180. And when you solve that equation, you get x equals 64. So those two angles are 128 each. They're not 128 each. I misspoke. Those two angles, one angle is 128 and the other angle is going to be 52. My apology, I misspoke there because they're supplementary angles. Now, 3y plus 20, we're going to solve for y, and you get that y equals 40. So the bottom angle equals 60 and the top angle equals 120. And again, those are supplementary angles. So now we're going to check your work. I need you to go back and check your work for the review and vocabulary. I'm not going to pause this time for this particular section. Hopefully you did this prior to starting the video and you had already done it prior. So here are the answers for the vocabulary. Congruent symbol is circled. We have an obtuse angle, a right angle, and an acute angle. If you need to get those, you should have paused back there. I guess you're going to have to go backwards. Our vocabulary is the interior is the inside of a figure. So interior is our word, and we're talking about that in this lesson because we talked about alternate interior angles and consecutive interior angles. So the interior of the circle contains point A in our drawing to the right. The interior of the angle contains point B. We're going to underline the correct word. Of course, we need to be able to see the drawing to do that. Underline the correct word to complete the sentence. The endpoint of an angle is called its vertex. So B is a vertex there. Write two other names for angle ABC in the diagram at right. We have angle angle 1 and angle B. Continuing on. Now it's time to pause the video. Complete the lesson check, then going to check your work. So it's time for you to pause the video. I'm going to continue on to the lesson check. I'm going to trust you to pause the video this time. I'm not going to double check you. So, continuing on. In the diagram at right, angle 1 and angle 8 are supplementary. What is a good name for the pair of angles? Explain. Circle the best name for lines A and B. A and B are parallel lines. Circle the best name for the list below for angle 1 and angle 8. They are on the same side of the transversal. So same side would be the appropriate selection. And finally, they're on the outside of the parallel line, so they're on the exterior. So we could call them same side exterior angles. And it looks to me like same side exterior angles would be supplementary angles, just like same side interior angles. All right, so that's our lesson for 3-2. It's dealing with parallel lines cut by a transversal and how the angles that are created relate. Remember that alternate interior angles are congruent, alternate exterior angles are congruent, and corresponding angles are congruent. And finally, same side interior angles are supplementary. For those who didn't take the vocabulary test yet, you're going to do that Monday morning when you come to school. So don't say I didn't warn you. Hopefully you watched the whole video and you found out that you need to take the vocabulary quiz first thing you come into school on Monday. Well, when you come to my class, third block on Monday. Hope y'all have a good weekend. I know it's going to rain a lot, so enjoy the time. This is the end of the video.